Hello everyone, nice to meet you all the participants of the International Conference on Computer Engineering Network and Intelligent Multimedia 2020. My name is Windu Antara Kesiman. Our team is from Virtual Vision Image and Pattern Research Group, Department of Informatics Engineering, Universitas Pendidikan Ganesha. We would like to present our work on profiling Balinese dances with silhouette sequence pattern analysis. So as you all already know, the traditional dances in Indonesia are very valuable artistic and cultural heritage. They contain a very deep philosophical meaning, represent the values of the social life of all Indonesian people. And especially for the Balinese dances, they are a very valuable asset for the tourism industry in Bali. And up until now, the process of creating new Balinese dances is still being carried out. The Balinese dance is still very popular, studied among the Balinese young generation. But the opportunity to get know and learn about the Balinese dance from the original maestros, of course, cannot be done directly. We can mention here some maestros and the masterpiece they created. For example, Wayan Limbak is the creator of the Kecak dance and also Pendek dance. We have also Ibu Swasti Wijaya Bandem, who created the Puspanjali dance. And Bapak Inyoman Kaler is the creator of several popular dances in Bali, for example, Margapati dance and Panji Semirang. The Balinese dance movement pattern characterized a masterpiece, and it should be passed down from generation to generation. So the Balinese dance learner can know the characteristic of the dance movement that contained in each of these different masterpieces. Our research is under the framework of the project of CompuDance, computerization of dances. This project seeks to analyze the silhouette pattern found in each Balinese dances from different maestros with the digital visual imaging techniques. It will provide the basic knowledge about the visual identities that may be found in each of Balinese dances from each maestro. We would like also to find out the similarities and the differences in pattern between different Balinese dances. And it will provide the visual information in quantitative measurement about the Balinese dance pattern from different number existing of the Balinese dances. And it will be very useful as the basis for further research in our effort to digitally create new Balinese dance pattern. So the urgency of this research lies on the effort to preserve the value of the national artistic and cultural heritage through the deep and comprehensive learning with the help of digital technology. So we can reveal and in the same time we can maintain the intrinsic value of each pattern of the Balinese dance movement. And we can introduce in the same time to the younger generation about the Balinese dance learning in the more enthusiastic and attractive way. The objective of our research is first to produce the first standardized dataset for Balinese dance video. This dataset will be very useful for further reference used by other researchers in the field of computer vision, especially in video sequence analysis. And we would like also to implement and to evaluate the performance of some proposed scheme for future extraction methods. We can mention here our back of visual movement that will be explained in the next slide. To do the pattern analysis for the digital image frame sequence. And the final goal is to find, to detect, and to extract the pattern of Balinese dance silhouette from some different maestros who created some masterpiece in Balinese dances. We will provide the quantitative analysis in the terms of computer vision field. You can see here the general scheme of our proposed method. It consists of 4 procedures. The first is the image frame extraction process, and the second step is the feature extraction step. The third step is the creation of the bag of visual movement from the feature already extracted from the image frame of the video sequence. And the last step is the pattern analysis, which is the detection and extraction of silhouette pattern by using the suffix tree analysis. So from the general schema, you can say that from each image frame extracted from the video, we will extract the histogram of gradient feature. For each image frame, it will provide n different layer of histogram of gradient, depends on the parameter that we are using in the histogram of gradient feature extraction. And then for the creation of the back visual movement, we will apply two process of clustering by using the Cummins clustering. The first clustering will be cluster each histogram of gradient layer from each different frame, and then we created the histogram from the different cluster of the histogram of gradient layer, and from that histogram we will apply the second Cummins clustering process to produce the final frame cluster code. And from this frame cluster code, we will create the sequence of frame cluster code to feed the pattern analysis module by using the suffix tree analysis. In this slide, you can see the visual schema of our proposed method. From a video of, for example, Tari Puspanjali, we will extract the frame, and then for each frame, we will extract the feature, and we applied the clustering process, as we already explained in the previous slide, to create a bag of visual movement. And this bag of visual movement will produce a sequence of frame cluster in the string format, and we send this string as the sequence of frame cluster to suffix tree analysis to extract some pattern from this dance. This is the detailed description about our each step in our proposed method. Here you can see that we extract the image frame from each video of Balinese dances. We extract a fixed number of 500 image frame from each video. You can see here the example of frame extracted from Tari Puspanjali, and then from Margapati dance, Viranjaya dance, and also Tari Chandrawasi or Chandrawasi dance. For the second step, we will resize all the image frame into the same pixel size, and we applied the Otsu binarization method to get the age of the silhouette of the dancer. And then we applied the histogram of gradient on the binarized image of the silhouette. You can see here the image on the right side of the presentation. For histogram of gradient parameters, we are using 4 pixels for the cell size, and with using 4 different orientations. So in the final feature factor of histogram of gradient, we have 16 different histogram of gradient layers. And the size of the factor dimension for the histogram of gradient, about 14,000 factor dimension. And for one video with 500 image frame, we have in final total of 8,000 histogram of gradient feature layers. The third step of bag of visual movement creations, it is inspired by the concept of bag of visual word that already used for the word spotting research. As I already explained in the previous slide, that for the back visual word creation, we applied 2 process of clustering. The first K-means clustering will cluster the histogram of gradient feature from all 8,000 layers. And then from this first cluster code, we will jointly build a histogram of cluster code from each 16 layers for each image frame. So for each image frame, they will have one histogram of cluster code from the first K-means clustering process. And we will apply the second K-means clustering based on each histogram of cluster code from each image frame of the video, and we will get another cluster code that will be served at the peak of visual movement. So here you can see the example of the frame cluster extracted from our method. The first cluster in red, and the second cluster and the third cluster in green. You can see visually that the K-means clustering are able to cluster each same silhouette movement from all image frame of the Puspanjali dance video. So from this 500 frame cluster code, we can generate the sequence of frame cluster code in text format. For example, here we can show you the sequence, the example of sequence code from 3 different sequence video. So these 500 codes will be sent to the pattern analysis module with suffix tree analysis. So suffix tree analysis is using to analyze the pattern of silhouette sequence. A suffix tree of a string here is a sequence of character code, is a tree that contains all paths to build all suffix tree of that string. In the left, you can see the example of suffix tree generated from the string ABBCCAC. The suffix tree is useful to detect and localize pattern in a string. For example, we can find easily the substring repetition and the longest common substring. On the right image, we present the example of the suffix tree built from one example of 500 sequence code that we generated earlier with the back of visual movement. And from this suffix tree, we can detect easily the pattern found in that sequence of 500 code, the pattern tree. For the experimental data set in our work, we have 8 different video of Balinese dances. This 8 video comes from 3 different Balinese dance maestro. You can see the table. In the table 1, we have 3 dances from the maestro Swasti Wijaya Bandung. We have 2 dances, Wiranjaya and Nelayan dance from Ketut Merdana. And we have 3 other dances, Margapati, Wiranata, Panji Semerang from Nyoman Kaler. All dances are classified as the female dance here. When doing this recording video, we done it uniformly to facilitate the detection process of the dances. No editing and no pre-processing step to enhance the quality of original resulting video was performed in our dataset. The female dancers only use black clothes and with basic accessories with light background to make it uniform for all video. Here is the result of the detected pattern from each dances. So the detected pattern is the sequence of code from image frame that appears at least twice in 2 different frame positions. In our experiment, we consider a pattern if the long of the pattern consists minimum 5 image frame. You can see visually here that our proposed method of histogram of gradient feature extraction with back of visual movement construction are able to detect pattern. The first example on the red pattern is from Puspanjali dance. The pattern detected comes from image frame of 1 180 and from 338. The other example for Margapati dance and also the Viranjaya dance. So here is the example of two different positions of frame sequence who share the same pattern of silhouette. To be able to analyze and measure the pattern of silhouette sequence quantitatively, we propose 13 different pattern measures. These 13 different pattern measures will serve to build a pattern profile of Balinese dance. So we have here total number of patterns and then the average number of patterns per feature layer. We also calculate the maximum length of pattern found in the video. And we have also the average length, other measurement about the maximum frequency of pattern per feature layer. And in the end, we also calculate the maximum distance from each pattern and the average distance between each pattern. These three tables show the final result in quantitative measurement from all dances in our dataset. So this measurement is very useful to give a profile of pattern analysis of each dances in our research. As some finding from this table, we can see here in discussion that Tari Chandrawasih has the least number of pattern. You can see here in the table, Tari Chandrawasih only have 4 patterns, while dance of Viranjaya and dance of Margapati have the highest number of patterns. So dance Viranjaya from Ikutut Mardana have 132 patterns, and Margapati have 133 patterns. This is also reflected in the values of average number of patterns per feature layers and the values of average percentage of pattern coverage per feature layer. So dance of Chandrawasih has more varied movements than dance of Viranjaya and dance of Margapati, because it is found that there are fewer of the same movements that are repeated in dance of Chandrawasih compared to more of the same movement that are repeated in dance of Viranjaya and dance of Margapati. Based on the value of average length of pattern, all Balinese dance in this dataset have an average pattern length of about 5 to 7 frames. However, dance of Viranjaya has a maximum pattern length of up to 21 frames, and dance of Panji Semirang has a maximum pattern length up to 18 frames. You can see here in the table. So in general, for all Balinese dances in this dataset, the values of maximum frequency of pattern per feature layer is only 2 until 3 times. We can conclude, based on our finding, that in this work, we already produced the first standardized dataset for Balinese dance video. Can be used for further reference and for other researchers in the field of computer vision, especially in the field of video sequence analysis. We already implemented and evaluated the performance of our proposed feature extraction methods using bag of visual movement. And we can see already visually that this bag of visual movement is able to differentiate the cluster for image frames, and our proposed method with histogram of gradient are visually able to detect pattern. Our proposed 13 pattern measurement is able to build the first pattern profile of Balinese dance. It will be very useful to be used to analyze and to measure quantitatively the pattern silhouette sequence, and it will be provide the initial quantitative profile of different Balinese dance from different maestros. For the future work, we plan to analyze the similarities and the differences between Balinese dance from different maestros by using this first quantitative profile from each different dances. So this is the end of our presentation. We would like to thank you for the organizer of the CENIM conference and all the participants of the CENIM 2020 conference for your time and our sharing of knowledge in this full perspective and future research collaboration work from our domain of research. Thank you very much.